In this video, we will be working on the SAT practice test number 10, and the calculator is allowed for this section. Okay, problem 1 says that a helicopter is initially hovering 40 feet above the ground. It begins to gain altitude at a rate of 21 feet per second. Which of the following function represents the helicopter's altitude, y, in feet, t seconds after the helicopter begins to gain altitude? Okay. If you look at these answers, these are all in y equals mx plus b format. So you know we're dealing with a xy coordinate situation, okay? Now, when you see a phrase like this, t seconds after the helicopter begins to gain altitude, that means t seconds is going to be the input value along the x coordinate, okay? So t seconds, and the output value is going to be the height. That's going to change depending on how far along we are after the helicopter initially begins to gain altitude. Now, the fact that this is height, let me write that down, and the helicopter gains altitude, that means whatever slope we're dealing with is going to be in the positive direction. Okay, so we're going to have something that looks like a positive slope. You see this phrase, initially hovering at 40 feet? Initially means t equals 0. So at t equals 0, we are going to be at the level of 40 feet. That tells us that that is our y-intercept. So immediately, I only am going to choose one of these that has 40 as the y-intercept. D does not, so let's cross that out. What else did they tell us? Gaining altitude, okay, that means positive slope, at a rate of 21 feet per 1 second. Anytime you have a change in y over a change in x of 1, you are dealing with the slope. This is the rise over the run with each change in 1 second. That means our slope is 21. So we are looking for something like this. Y equals 21t plus 40. Y equals mx plus b. Slope is 21. Y-intercept is 40. Therefore, it is going to be choice B. Next problem. It is so important to recognize, folks, that the slope is the change in the y value for every one change in the x value. Okay, next problem number 2. A text messaging plan charges a flat fee of $5 per month for up to 100 text messages sent, plus 25 cents for each additional text message sent. Which of the following represents the cost, y, of sending x texts in a month? Okay. So a couple things. Again, we have an xy coordinate. They tell you that the cost is y. So you know dollars are here. And you know here is going to be text messages. Okay, so as the text messages change, the cost goes up. Whenever you see a term like flat fee or initial fee, that's your y-intercept. That is where the number of text messages equals 0. So let's look at these choices. And it looks like they all start at 5, so we can't rule any of them out. Now, the $5 holds for up to 100 text messages. So here's $5 holding to up to 100, so that stays. This one is okay. C, we're going to cross out because it doesn't stay at $5 up to 100, and the same thing with D. We're going to cross that out. It has to stay steady at $5 until we reach an input of 100 text messages. Okay, so it's going to be A or B. Well, just looking at these two graphs, what do you think it's going to be? As your text messages increase, the cost is not going to go down, so it's got to be A. Next problem, number 3. Jake buys a bag of popcorn at the theater. He eats half the popcorn during the first 15 minutes. After eating half the popcorn, he stops eating for the next 30 minutes. Then he gradually eats popcorn until he accidentally spills all the popcorn. Which of the following graphs represent the situation? So the first thing I do is I look at all the graphs and I just make sure they're plotting the same thing. And they are. We have the amount of popcorn in the bag and we have time. All right, so as we look at these, we know that there's no mention in this paragraph of him going to buy popcorn. So any graph that features the amount of popcorn increasing cannot be a choice. So here we see the amount increasing, so it cannot be A. And we also see the same thing happening here in choice C, so it can't be C, and it can't be D. So the choice has to be B. All right, so it's just that quick. Now let's just double check to make sure that we didn't do anything wrong. First 15 minutes, he eats half the popcorn. So here's the original amount. It drops to half in the first 15 minutes. Each of these tick marks represents 15 minutes. Okay, then he stops eating. Let's see, he eats half of the popcorn. After eating, he stops for the next 30 minutes. Now, I don't know how anyone can stop eating popcorn after eating half of it, but that's apparently what happened. So for 30 minutes, he is not eating. That means the amount stays the same for 30 minutes. Here's 15 minutes, another 15 minutes. Then he gradually eats the popcorn. Here's a slope, a gradual slope. And then he dumps all the popcorn out accidentally, and it drops to 0. So it is B. Next one, number 4. So here, this one's pretty straightforward. If 20 minus x equals 15, what is the value of 3x? So here, we're just going to solve for x, and then we're going to end up multiplying by 3. So what I like to do in this situation is I'm going to throw the negative x on the opposite side in my mind, so I know I'm going to have x. Then I'm going to throw 15 to the opposite side, so it's going to be minus 15. I'm going to end up with x equals 5, and 3 times 5 is 15. Number 5. If f of x equals x plus 3 over 2, what is the value of f of negative 1? So what you do here, folks, is you pattern match. And you see that instead of f of x, they want you to do f of negative 1. So wherever you see an x, you're going to replace that with negative 1. So you're going to have negative 1 plus 3 over 2. And that's going to be 2 over 2 or 1. So the choice there is going to be C. Let's move on. We are now on number 6. Which of the following is equivalent to this expression? Okay, notice all of these here in the answers, they have 2 terms. And here we start out with 2 factors. That means we must have distributed here. So if we distribute 2x times x squared, I'm going to do that over here. Recall that when we're multiplying and we have the common base, we are allowed to add the exponents. So essentially what we have here is 2x cubed. Okay, the 2 doesn't change. There's a hidden 1 over here in front of this x squared term. So in essence, this is 2 times 1 times x squared, and that gives you 2x cubed. The second distribution is going to be 2x times negative 3x. Let's write that down. 2x times negative 3x. So again, you are allowed to redistribute these numbers. If they bother you in this orientation, you can always do this, because multiplication is commutative. So now you're going to have negative 6 here. These become x squared because there's a hidden 1 in both of these exponents. And again, when you're multiplying and you have a common base, you add the exponents. So our answer is going to be 2x cubed minus 6x squared, or D. Next one. Okay. A retail company has 50 large stores located throughout the state. A researcher believes that employee satisfaction varies greatly from store to store. Which of the following sampling methods is most appropriate to estimate the proportion of all employees of the company who are satisfied? Okay, a couple things that I get from this paragraph, even without looking at the answers. Whenever you see survey, in your final answer, you'll want to see the word random. When you see random, that's the gold standard of surveys. Because random means the survey is not biased, there's no advantage to one person or another, there's no discernible difference between any of the respondents. Okay, so the first thing I kind of scan through here, and I see the word random in A and B, so I know these are looking good for me. I don't see the word random in here, so chances are it's not going to be C or D. But let's hold off crossing them out. Okay. The researcher believes that employee varies greatly from store to store. Okay, that tells me right there that we can't just rely on one store or a handful of stores, because there's a lot of variation between the stores. Okay, so let's take a look at them. We're looking for random, and we're looking for more than one store, or as many stores as possible. Okay. Selecting one of the 50 stores, immediately it's no good. Selecting 10 employees from each store at random, and then survey. Okay, that looks good. Okay, let's put a little mark there. Surveying the 25 highest paid. Okay, number one, we don't see the word random. And number two, highest paid means that there's a difference between these 25 employees and these 25. You don't want that. You don't want any difference between the respondents. Okay, so I don't like this one. And creating a website in which employees can express their opinions, and then using the first 50 respondents. Okay, again, this first 50 respondents is a bias. For example, maybe they create the website and the people that work on the day shift get to the website sooner, but the folks that work the night shift, they can't get to the website, so you never even get their opinion. So that one's no good. Answer of that one is B. Okay, let's go to number 8. The two graphs show total amounts of money that Ian and Jeremy each have deposited into their savings accounts for the first 7 weeks after opening the account. After they made the initial deposit, how much more did Ian deposit each week than Jeremy? Okay, so how much more did Ian deposit each week than Jeremy? Okay, here's the number of weeks, total amount deposited. Whenever you see that phrase, each week, and the number of weeks is along the x-axis, that means you're dealing with the slope. You want to know what's the change in the y value for the change in each 1 week. That means we're dealing with slope. So what I'm going to do here is I'm going to ignore the initial deposits, because they want to know how much was deposited each week. So I'm going to get the slopes of each of these graphs and compare them. Okay, so what's the slope of Ian? Okay, 1 week, 100 increase. It goes from 100 to 200. So Ian is going to be doing 100 per week. Jeremy, his curve is flatter, so I know it's going to be less. Here, if you move from this point to this point, in 1 week, there's a $50 increase. Therefore, the difference between the two is 50. Number 9. Another h of x situation, we pattern match. Instead of h of x, we do h of 5 and h of 3, meaning everywhere you see x, you put a 5, and everywhere you see x, you put a 3. So if we do h of 5, that's going to be 2 to the 5th power minus 2 to the 3rd power. Okay, so here you can't do anything with combining these exponents. For example, if they had given you x to the 5th minus x to the 3rd, you cannot combine these. However, because everything is in numbers, you can evaluate them. Folks, I want to tell you that 2 to the 3rd is the star of the SAT. Okay, I'm going to highlight that. You will see 2 to the 3rd all over the SAT. So I want you to go ahead and memorize that as being 8. Okay, 2 to the 5th, you can think of as 2 to the 3rd times 2 squared, or 2 to the 3rd is 8 times 4 is 32. So it's going to be 32, which is 2 to the 5th, minus 8, which is 24, or choice C. Number 10. Okay, we got another research situation. Okay, they tell you random sample. Okay, again, gold standard, random. From a large university, how often do they see movies? Using the data, he or she estimates that there's 23% of students in the population saw a movie at least once a month. The margin of error is 4%. Which of the following is the most appropriate conclusion, about all students at the university? Okay, so he estimates that 23% watch movies at least once a month. Greater than or equal 1 per month. There's a margin of error of 4%. So that means the minimum is 19% of the students and the maximum is 27%. Okay, so he's estimating here that between 27 and 19%. Here's our range. Okay, let's look at the choices. It is unlikely that less than 23% of the students see a movie. Not really, okay? If it had said it is unlikely that less than 19% of the students, that might be a choice. So I'm going to go ahead and cross that out. At least 23%, but no more than 25% see a movie. No, the range goes up to 27%. The researcher is between 19 and 27% sure that most students see a movie. Assuredness has to do with confidence. So I'm going to put a tick mark. I don't like that one, but I'm not completely ruling it out. D, it is plausible that the percentage of students who see a movie at less, okay, I like this one. You see this word, these complex of words, it is plausible. That's a very forgiving phrase. So it's really hard to cross that out as an answer. So I'm going to choose D. To me, I like D better than C for the reasons I mentioned. Okay. Next one. We're up to number 11, but let's erase this. Okay, what's going on here? So here we have a couple of lists, and they want to know about the mean and the standard deviation. Okay, so the first thing I'm going to do is take the mean. Another word for mean is the average. So both lists have 6 numbers, 2, 4, 6. So I'm going to add all of these and get the sum and divide that by 6. So list A is going to be 3, 6, 10, plus it's going to be 21 when you add them. So the mean of list A is going to be 21 over 6. And list B is going to be 5, 8, plus 8, 16, plus 5, 21. So they have the same mean, 21 over 6. Okay, so the means are the same. Okay, so it can't be C or D. It's got to be A or B. So now they talk about standard deviation. What is standard deviation? Standard deviation is the average distance from the mean. So if you have the mean here, or the average, have two sets of points. I'll do them in different colors. They have the same mean. Okay, you could have one group of numbers that are very close to this mean, and then you could have other group of numbers here, same mean, but the points are further from the mean. Okay, so whatever distance this is from the mean, for each given point, you take the average of that, and that's the standard deviation. But numbers that are more spread out have a larger standard deviation than those that are located close together. Okay, so let's erase this. And let's look at the data in terms of how far they are from the mean. So I think the only way to do this problem is really look at each point and figure out how far it is from the mean. So we have yet to compute the mean. 21 over 6 is going to come to 3 3/6, which is 3 1/2, which is 3.5. So I'm going to compare the distance between each of these points to 3.5 and then go from there. So up here in list A, the first one is 2.5 away. The next one is 1.5 away. So I'm just basically doing 3.5 minus each of these numbers. Okay, so 3.5 minus 2 is going to be 1.5. This is going to be 0.5 away. This is going to be, and I'm doing the absolute value of it because I don't care if it's negative or positive. This is 0.5, this is 1.5, and this is 2.5. Okay, I'm going to do the same thing with the other list. So this is going to be 1.5 away. This is going to be 0.5, 0.5. This is going to be 0.5, 0.5, and 1.5. Okay, so you could see that these standard deviations are not the same. It looks like the red values are further away. So therefore it's got to be A. Mean is the same, standard deviation is different. Okay. Number 12. A book was on sale for 40% off its original price. If the sale price of the book was $18, what was the original price of the book? Okay, so folks, we're going to use this formula here. New equals original times 1 plus or minus R, where R is the percentage rate in a decimal format. All right, so it was on sale for 40% off its original price. So if you have the original price here and you take 40% off, what's left? 60% of the original price. They tell you that the final price or the sale price of the book was $18. So that's going to be the new price. The original price we don't know, let's call that X. But we do know we're looking for 60% of that original price. So whatever X computes to, that's going to be our answer. All right, so look what we did here. The new price equals the original, which we don't know, times 1 plus or minus the rate. So we have 40% off. So 40% off means we're going to use minus. So 1 minus the decimal version of 40% is going to be 0.6%. All right, so let's compute this. I know we have access to the calculator, but I'd like you folks to know how to do this without a calculator, in case a problem like this shows up in the regular section. Okay, so we're going to divide both sides by 0.6. So we're going to get X is going to equal 18 divided by 0.6. So we're going to put 18.0 in the box. And because this is 0.6, we got to move that over. Once we move the decimal point, we put it up. 6 goes into 18 3 times, and your final answer is going to be $30 or C. If you like fractions, which I do, and you have x equals 18 divided by 0.6, you can rewrite 0.6 as 6/10. So you have 18 over 6/10. That's the same thing as saying 18 divided by 6/10. I'm going to change that to 18 over 1. I'm going to use keep change flip. I love it. Keep 18 the same. You change division to multiplication, and you flip the second fraction. 18 and 6 cancel, and you get 30 as your final. Next one. Question 13 is going to refer to this table. So let's analyze this a little bit. Here's the title, Insect Count for 3 pesticide treatments. Number of insects on the y-axis, weeks after initial treatment on the x-axis. And you have 3 colonies. Okay? I like to get a sense of what I'm looking at. 3 colonies of insects were each treated with a different pesticide over an 8-week period. Okay, so here's our 8-week period. A, B, and C were treated with pesticides A, B, and C. Each was applied every 2 weeks over the 8-week period. Okay, so here we go. Every 2 weeks, each of these colonies are getting hit with a pesticide. The bar graph shows the insect counts for each of the colonies. So here's the number of insects, and as you would expect, overall the insects are going down. First question. Which of the following colonies showed a decrease in size every 2 weeks after the initial treatment? So let's look at colony A. Starts out at 80 and goes down consistently. Colony B is in the middle with the dots. Down, 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 down. Finally, colony C, which is in black, it goes up. So between the initial treatment and 2 weeks after it goes up, so it can't be colony C. So 3 is out, so it has to be 1 and 2 only. Okay, number 14, still referring to this table. Of the following, which is closest to the ratio of the total number of insects in week 8 to the total number at the time of the initial treatment? Okay, so it's going to be the total in week 8 versus the total at the time of the initial. Okay, so we're looking for this total here to that here. We know that this total here is smaller, so we're looking at a ratio where the first number is smaller than the second. Okay, and that's true in all of them, so we can't cancel any of them out, any of the choices out. Now you see this phrase here, which is closest? That's a license to round off as you do this computation. Okay, so let's be very liberal in our rounding off process. For example, you see this bar here, how it's close to 20? I'm going to call that 20. So let's proceed. So the total in the numerator, the total at week 8 is going to be 20 plus this value here. It looks to me to be between halfway between 0 and 20. I'm going to call that 10. And halfway between 40 and 60, I'm going to call that 50. At the time of the initial treatment, which is here, we have 80. Plus here, I'm going to call that 60, and I'm going to call that 60. So I'm going to call both of them 60 or 120. That's going to give us 80 over 200, or 8 over 20, or 4 to 10, or 2 over 5. So I'm going to call that choice A. Next one. Okay, we are now on problem 15. A right circular cone has a volume of 24 pi cubic inches If the height of the cone is 2 inches, what is the radius in inches of the base of the cone? So the first thing you want to be careful about here, folks, is units. Okay, so it looks like height and radius are both in inches, and we're in cubic inches. The volume of a right circular cone is going to be 1/3 pi r, 1/3 pi r squared h. Okay, now a right circular cone comes initially from a cylinder. And if you look at the volume of a cylinder, it's the area of its base, or pi r squared, taken through a length in space of h. So the volume of a cylinder is pi r squared h. But when you have a cone, that cylinder gets taken to a point, if you will, like this. So the fact that it's coming to a point means that the volume of this cone is only 1/3 that of the original cylinder. That's the derivation of that formula. Okay, so they tell us here that the volume is 24 pi cubic inches. So we're going to say 1/3 pi r squared h equals 24 pi. Now you see how pi is on both sides of the equation? That means we can divide both sides by pi and the pi cancels out. So I'm literally just going to erase it. The next thing I'm going to do, since they tell us the height is 2 inches, I'm going to replace that with 2 inches. So now we have 1/3 times r squared times 2 equals 24. I'm going to rewrite that as 2/3 r squared equals 24. Okay, all I did was take this 2 and put that in the numerator. All right, so we're trying to solve for r. So what I'll do here is I will multiply by the reciprocal of 3/2, both sides, to get rid of that fraction. This becomes 1. So now I'm going to have r squared equals the 24 and the 2 become 12/36. Now to get r, we're going to take the square root of both sides, and whenever we do that, whenever we're taking the square root of something, we have to add plus and minus to the opposite side. So the square root of r squared becomes r, and the square root of 36 plus or minus becomes plus or minus 6. We're going to go ahead and reject the -6 because we're dealing with the length of the radius, so therefore our answer becomes just +6, or choice B. Number 16. In 2015, the populations of city X and Y were equal. From 2010 to 2015, the population of city X increased by 20%, and that of city Y decreased by 10%. If population of city X was 120,000 in 2010, what was the population city Y in 2010? So you see these words, what was the population, or you might see how many such and such. That's our unknown right here. So as I set this up, I'm going to have 2 years here, 2010 and 2015. I'm going to use the variables X and Y, and I'm going to put Y as the population in 2010 for city Y. Okay, so what is going on here? What else do we know? We know that city X in 2010 was 120,000. So I'm going to put this up here for city X. We also know that between 2010 and 2015, city X increased by 20%. Remember what we talked about in an earlier problem. New equals original times 1 plus or minus r, where r is the decimal version of the percentage. So if we're looking at city X increasing by 20%, 20% is 0.20. So since things are increasing for city X, The new value is going to be the original, which we know is 120,000, times 1 plus 0.20, or it's going to be 120,000, I'm going to write it up here, 120,000 times 1.2. Okay. What else do they tell us? City Y decreased by 10%. So let's go down here and use the same exact setup. Okay. City Y is an unknown. So for the city Y original, I'm going to use the variable Y. And then, since it's decreasing by 10%, the decimal version of 10% is 0.10, and since we're decreasing, I'm going to use 1 minus 0.0 or 0.9. So in 2015, after a 10% decrease, in 2015, we're going to have 0.9 of the original population of Y. Now, don't forget, first sentence, they told us that in 2015, the city had equal population. So now we can set these two equal to one another. So let's see if I can find some space. We're trying to solve for Y. So I'm going to put up here, let me choose a different color. Let's use green. Up here, we're going to say 0.9y equals 1.2 times 120,000. Divide both sides by 0.9. And when you do this computation, y equals 120,000 times 1.2 divided by 0.9, you get 160,000, which is choice C. We are now on problem 17. The volume of a sphere is given by the formula V equals 4/3 pi r cubed, where r is the radius. Which of the following gives the radius in terms of the volume? So folks, when you see this phrase in terms of, that means they want you to solve for the radius. Okay, so we're going to get something where radius equals, and we're going to get something else on the opposite side of the equal sign. They usually have a similar problem like this on every SAT exam, and this one is relatively simple formula, but sometimes they'll give you something crazy and they'll go into the explicit detail. They'll give you something like this. And they'll go into an explanation of what capital M is and L is and HZ, and folks, just ignore all the verbiage. And at the very end, they're going to have something like this. What is the N value in terms of L, M, H, and Z? And all you do is solve for N. So just, if you see that, just go right to the last sentence and solve for whatever variable they want you to solve for. All right, so this becomes an algebra problem as to how we're going to solve this. So we have volume equals 4/3 pi r cubed. Okay, the first thing you need to recognize, folks, is that this pi and this r cubed are really pi over 1 and r cubed over 1, meaning the pi and the r cubed belong with the 4 up in the numerator. So the first thing I might do here is I might rewrite this as volume equals 4 pi r cubed over 3. The next thing is you really want to isolate the r cubed first. So what I'm going to do is I'm going to multiply by the reciprocal of the 4 pi over 3. So let me do that in a different color. So on this side of the equation, I'm going to multiply by 3 over 4 pi. I'm going to do the same thing over here. And I'm also going to put this v over 1 to remind myself that that v is in the numerator with the 3. All right, this is going to cancel out everything on this side of the equation except for the r cubed. So this goes because of the 4 pi in the denominator, that 3, and that 3 go away. So we are left with the following. We have r cubed equals 3v over 4 pi. All right, I'm going to erase everything here and clean this up. So in this scenario, the way we get r by itself is to take the cube root of both sides. And that's because taking the cube root is the same thing as raising everything to the 1/3 power. So if I take the cube root of 3, the cube root of r to the 3rd, this becomes r, and this is your final answer. So that's going to be choice D. Now on 18. Okay, what's going on here? Okay, this is a probability problem. And when you have probability problems, it's important to really isolate the following. That is, the number of quote-unquote successes over the total possibilities. Okay, so I'm going to keep that in mind as I read through this problem. The table shows a survey in which a tablet users were asked how often they watch video in order to get content for free. Based on the table, which is the closest to the probability, okay, that gives me the license to round off, that a tablet user answered always, given that they did not answer never. Okay, so what I'll do in this scenario is I look at these percents and make sure they add to 100. So 31 plus 24 is 45, plus 13 is 58, plus 30 is 98, and when you add these decimals, that gets us to 100. So I look at this as 100 people. Now, okay, probability that they answered always. So if the probability that they answered always was as is, you would say 30 over 100. But they exclude a certain number of people. So they say the total possibilities is that the students did not answer never. So how often did they answer never? I'm going to call that 30%. So if they answered never 30%, how often did they not answer 30%? The answer is 70. Okay, so 30% said never. That means 70% did not answer never. Now they want to know how many answered always. Well, now you have 30 over 70. So when I look at that, I say to myself, okay, that's 30 over 70 is a little bit less than 50%. That's 45%. Choice C. 19. In the equation above, A is a constant. The graph of the equation is a parabola. Which of the following is true about the parabola? Okay, so what they have here is minimum, maximums, etc. Folks, when you have parabolas, when they say minimum, maximum, they're referring to the vertex. So we need to find the vertex given this formula. All right, let's talk about parabolas a little bit. It's so important for the SAT. Here's the formula they want us to analyze, and they want us to find the vertex from that. Folks, this yellow equation that they gave us is already in vertex form. Okay, so let me write that down. Vertex form. And this red equation is a generic form of the vertex formula. So when you see the word vertex form, that means just by looking at this, you can tell what the vertex is. It's very similar to the scenario where you have slope-intercept. Formula for a line, which is y equals mx plus b. So why do they call this the slope-intercept form? It's because you could see the slope, it's right here, and you can see the y-intercept right off the bat. That's where these terms come from. So here, we can see the vertex here. All right, now look at the difference between these two formulas. If I wrote this equation down, and I asked you what was the slope, you would say 5. And I asked you what was the y-intercept, you would say b equals -2. Notice, you didn't flip any signs. This slope, as written, this yellow equation, y equals positive 5x, you told me the slope was positive 5. And when I asked for the y-intercept, you said it was -2. You didn't flip any signs. And the reason, folks, you didn't flip any signs is because this generic formula does not have any negatives in it. Now, compare and contrast that to the vertex formula. You see that negative right there? That means whatever you see in this yellow equation, when you're finding the vertex, you take the opposite of what you see. Here, when you find the k value for the vertex, you're going to take exactly what you see because of the plus sign in the generic formula. So let's do that. We are looking for the vertex. The vertex is going to be hk. The way I like to do this is, because of this negative sign in the generic formula, I put a circle around the integer and the sign in the formula they give you. And as I pull it in to my parentheses as the final answer, I flip the sign. Here, I don't have to do that. So I circle this, and I keep this exactly as is. Plus a. So folks, that's going to be your vertex. Plus 3 plus a. Okay, so let me write that down before I forget it. Now, that means it's going to be B or D. So let's cross out A and cross out, let's see, C. Okay, now, one is a minimum, one is a maximum point. You see that minus sign right there? That means this parabola opens upside down. So if it's an upside down parabola, which it is because of that negative sign, then this vertex has to be a maximum. Choice D. Okay, for number 20, they say the maximum value of a data set consisting of 25 positive integers is 84. A new data set consisting of 26 integers is created by including 96 in the original. Which of the following measures must be 12 greater for the new set versus the old set? Okay, so you have a set of 25 here, an original set. And they tell you that the maximum, let's see, the maximum value is 84. Then they have another set which includes the original set plus the number 96. Okay, so we know that the maximum is no longer 84. We know that the maximum is 96. Okay, so let's look at each of these terms. You have to know what they mean in order to solve this problem. So the first one, the mean, another word for that would be the average. Next is the median. The median is the middle number. C is the range. That's the difference between the minimum and the maximum. And finally, D is the standard deviation. That's the average distance from the mean. Okay, now folks, this set could be anything. Positive integers could be anything. So they could be all ones. This entire set can consist of 25 consecutive ones followed by 84. In which case, that 96, if you add that, would change these, the mean and the median, in ways that you can't predict. Because you don't know. The set could also be 84 consecutively listed 25 times. So here's the bottom line. So in other words, 96 added to this set that consists entirely of the number 84 written down would do different things versus a set which consisted of 1 written down 25 consecutive times. You couldn't guarantee that this 12 greater will apply. The only thing you can guarantee is that the range changes because the maximum changes. So if the range is the minimum to maximum, okay, the minimum doesn't change. Whatever it is, whether it's 1 or 84, the minimum is not going to change, but the maximum changes by 12. Therefore, it has to be choice C.